Right folks, we're going to skip chapter 18, which is a load of graphs, and we're going to look at the man, the myth, the legend, Pythagoras. Okay, so this is a right-angled triangle. It's called that because it's got a right angle. These are amazing facts, I know. The longest side of a right-angled triangle is called the hypotenuse. Think it's a Greek word meaning longest side. The other sides we don't really care about, so we'll just call them sides. What we're going to introduce here is Pythagoras' theorem, which only works for right-angled triangles but is really powerful. And it's this. The side squared here plus the side squared here gives us the hypotenuse squared. And what that lets us do is if we have a right-angled triangle and we know two of the sides, we can always work out the third side. So if we have two sides, we can find the third side. So let's look at some examples of this. Let's set out our theorem to start with. We probably want to label the side that we think is the hypotenuse. Now remember, the hypotenuse is opposite the right angle. So x is our hypotenuse here, x is our hypotenuse here, and although it's on the bottom, it's still opposite the right angle, it's still along the side, x is our hypotenuse here. Then we need to think about using the formula. So we're going side squared plus side squared is hypotenuse squared. Our sides are 3 and 4 in this first example, so 3 squared plus 4 squared equals x squared. For the second one, we could get to 12 squared plus 30 squared equals x squared. And then for this one, just got to be a little bit careful. This has got centimeters, this has got millimeters, so we want to change these to the same units before we do anything. We'll make this 50 millimeters. But then we'd get our formula would be 50 squared plus 33 squared is equal to x squared. So that's using our theorem. What we actually want to do though is find the missing side, so we need to find what x actually is. And well, let's do the obvious steps. Let's work out what 3 squared plus 4 squared is. It's going to be 9 plus 16, so that's 25. So we're saying 25 is equal to x squared. How do you get rid of a square? You use a square root. So our actual value of x is the square root of 25, which is just 5. So the missing side of that triangle is 5 centimeters. For the second one, do the same thing. Do 12 squared plus 30 squared. Get yourself to 1044. That's x squared. So we want to square root it to get what x actually is. And that'll give us 32.31 centimeters. Again, do notice I'm rounding to 2 decimal places because the questions told me to do that. You would lose marks if you rounded to 1 decimal place. For the third one, 50 squared and 33 squared, that's 3589. And then we want to square root that, so 3589 square rooted gives us 59.91 millimeters, because we did change the units to millimeters. And that's Pythagoras' theorem. It's really useful. Now, what we're going to do for the rest of this lesson is look at different ways of applying it and applying it to like application questions. But that's it as far as new things for today goes. So what about these? Why am I putting these as different questions? Well, you do have to be careful about which side you say the hypotenuse is. It's not always the x. It is always the side that is opposite the right angle. So our hypotenuse is the 13 on that first triangle. It's the 40 on the second triangle, and it is the x on the third triangle. Now if we remember our formula, which is that the side squared plus the side squared is equal to the hypotenuse squared, we can then set some stuff out that's going to look a little bit different to what we had on the previous page. Here we're going to have 12 squared plus x squared equals 13 squared, side squared, and hype squared. For this second triangle, we're going to end up with 37 squared plus x squared equals 40 squared. For this next one, again, units. We've got centimeters, we've got millimeters. I think I'll change them both to centimeters this time because 8 feels quite easy to work with. Let's use 8. We'd have 11 squared plus 8 squared equals x squared. Again, side squared, hypotenuse squared. And then what you've got to do with these depends on where the x squared is. So in this instance, in the first one, we need to actually subtract that 12 squared from our 13 squared. because it's on the, to move it to the other side of the equation, we need to subtract it. For the second one, we're going to subtract our 37 squared. And then for the third one, well, we can add those together. X squared is isolated here, that's fine. From that point, you just do what's in front of you. We'll do 13 squared take away 12 squared, and we'll get that it's 25. And then we can do the same thing we did before and square root that to get that x is 5 centimeters. On the second one, we'll subtract those and get ourselves 231. But remember, again, that's the square. We need to square root it, and that'll tell us 15 point. Let's go to 2 decimal places again. 20 centimeters. And then for the third one, well, we can add those together. So 185 is x squared. We want to square root that to get what x actually is, which is going to be 13.60 centimeters, because we changed them to centimeters. So there's essentially two different types of Pythagoras questions you can get. You can get ones like the first two, where you have to subtract, and you can get ones like the third one, where you have to add. Now, a way of remembering that is if you're finding a side, you subtract. You can put the s's together like that, and if you're finding a hypotenuse, you add. So if we're finding a side, we subtract. If we're finding a hypotenuse, we add. But obviously the other way of doing it is just remember the formula, put things in the right place, and rearrange it sensibly. So I've written down the summary of what we just said there. Again, I'll remind you that the equation we want to be using is side squared plus side squared equals hyp squared, although most textbooks will have this as a squared plus b squared equals c squared, and if you've already used that in the past, that's perfectly fine. I just prefer my one. I'd like you to try these two, and let's see what you get. Okay, so pause the video, and let's see what you got. So label our sides. The hypotenuse is always opposite the right angle. Then we need to write down a suitable equation. 7 squared plus 10 squared equals x squared, and in this one we've got 12 squared plus x squared equals 15 squared. We then want to work them out. So our first one is going to give us 149 is x squared. We can then square root that to get what x actually is, which is going to be 12 and a bit centimeters. For the next one, we need to do the subtraction. So we're going to do x squared is 15 squared, take away 12 squared, which in this case is going to give you 81. And so we'll square root that to get what x is, which is 9 centimeters. Hopefully you got them right. Okay, let's look at one little application of this then. So we've got here our triangle again. We've got a missing side, which we can pretty much instinctively just call x. Our hypotenuse is clearly the 25, so this is a subtract question. So if we want to find x squared, we're going to do 25 squared minus 7 squared, which is 496. So x is the square root of that, which is just 24 centimeters. Okay, great, we've done Pythagoras, but the question isn't find the missing side of your shape. The question is find the area and the perimeter of this triangle. Now the area is a half base times height, and the perimeter is just add all the sides together. So what we need to do is then apply what we figured out to those formulas. So our area is a half times base times height, so a half times 7 times 24, which is going to give us 84 centimeters squared. And our perimeter, that's all of the sides added together. That's 24 plus 25 plus 7, which is going to give us 56 centimeters. Now, as I said, those are the basics of Pythagoras, and there's loads of stuff you can do with this. We're going to err on the side of number work this week, and we'll maybe look at using it with algebra next week. But I wanted to introduce some shape questions, essentially. So we're going to look essentially at finding areas and perimeters using Pythagoras. Now we're dealing with a triangle here, so it's worth remembering that area is a half times base times height, and perimeter is just all the sides added together. So we need either to find the height, which is the h here. We do have all the sides actually, so perimeter should be fairly straightforward in this case. Let's do that first then. So perimeter is just, because this is isosceles, 9 plus 9 plus 4, 22 centimeters. Now for area, we need to know the height. So how can we do that? Well, this isn't a right angled triangle, but it is if we cut it down the middle. So let's draw that bit that we've cut down. We've got this side being h, we've got this side being 9, and we've got this side here being 2 because it's half of the 4. Okay? So we've now got a right angled triangle. We can identify the hypotenuse as being 9. It's kind of unfortunate having two h's there. Maybe I'll relabel this as x for now. And I'll say, okay, let's do my formula. X squared plus 2 squared equals 9 squared. So this is finding a side, so I'm going to subtract 9 squared, take away 2 squared, and that equals 77. And then if I actually want to find that, I can square root my 77, and I can get that x is something horrible like 8.77 centimeters. Okay, great. So I can go back to my diagram and I can write down that this is 8.77. So we can now find the area to half times base times height. So a half times, let's use the whole triangle, half times 4 times the height, which is 8.77. And that gives us an overall area for this of 17.55 centimeters squared. So what about with this one? Well, I'd say with all the examples that are left to go, it's well worth you having a go first and then seeing what I come up with. So pause as and when needed. This is an equilateral triangle this time. So that means that all the sides are going to be the same length. So it means we can label this as being 10 and we can label this as being 10. And we're going to take some inspiration from the last question and just draw a line down the center. We don't know what that is, so we'll call it x, but it is the height of our triangle. If we want to find the area, we're going to need the height. We know this is a right angle because we've got a line going straight down to a horizontal line. And so we can say that this bit here is 5. And then we've got our right angle triangle. So draw it out, make it a little bit neater than what I'm doing. We've got hypotenuse of 10. We've got a side of 5. We've got a missing side. So what we want to do, let's jump straight to the shortcut this time. Actually, let's go. We know we're finding a side. We know we're going to do a subtraction. Let's do 10 squared minus 5 squared is equal to 75. And that's our x squared. Let's square root that to get our x, which is 8.66. And then let's actually go and find area. So area of this triangle is a half times base times height. So it's a half times base, which is 10 for the whole thing, times the height, which we found was 8.66. We get 43.3 centimeters squared for our area. Perimeter, fairly easy in this case. It's just 10 plus 10 plus 10. And we don't count the x because that's inside the shape. We just want the lengths on the outside, 30 centimeters. Okay, what about this one? A little bit more complicated. We want to find the perimeter and the area of this trapezium. Now, you might be thinking this doesn't look like a trapezium because a trapezium is meant to look like this with A and B, and it's meant to be the case that your area is A plus B over 2 times the height. And yeah, on most of the drawings you do in your book, that's what a trapezium looks like. But all a trapezium is two parallel sides joined together any which way. So maybe it makes sense to first flip this diagram on its side and say, well, we've got 14 here, we've got 8 here, and we've got 12 here. Now you can actually find the area of that trapezium already. We've got the A, which is 8, we've got the B, which is 14, and we've got the height, which is 12. So we can just work that out. That'll be 11 times 12, which is 132 centimeters squared. So the bit where we actually need to use Pythagoras here is for the perimeter, because we want to find this long side here. And then we can add 8 and 12 and 14 to it. Now again, we're going to draw a line straight down. We're going to put in a right angle on the corner. We're going to identify the hypotenuse as being the x in this case. And we can fill in the rest of the bits. So we know that this length here is 12. And what about this one here? Well, the top was 8, the bottom was 14. So we could split that 14 up into being an 8 and a 6. So we've got our right angle triangle. Again, I'd encourage you to write out your right angle triangle again before you start doing anything with it. We've got x and 12 and 6. We want to find x. This is a hypotenuse that we're after. So we're going to add. So we can go straight to saying 12 squared plus 6 squared is equal to our x squared. So we'll get the x squared is equal to 180. X is the square root of 180, which is equal to 13.42. And then we want the perimeter of this shape, so we're just going to add up, again, the trapezium. We're going to add up our 14, our 12, our 8, and our 13.42, and that will give us 47.42 centimeters. Okay, let's increase the difficulty one more notch. This is one of the famous double Pythagoras questions, because you have to actually use Pythagoras twice. We want to find the perimeter and the area of this quadrilateral. I'm going to start by trying to find this x here. Now that's a hypotenuse, so we'd need to use this side 11 here, and we'd need to use this side here, but we don't know that either. So I'm going to need that to find x, so I'm going to call that y. And I'm going to have to try and find what y is first. And I'm going to do that by thinking about the little right-angled triangle here. So our little right-angled triangle has a base of 7, a side of 6. We're trying to find y, which is the hypotenuse, so we're going to add them. So 7 squared plus 6 squared is equal to 85, which is equal to our y squared. And then we're going to square root that to find out what y is, which is going to give us 9.22. Okay, we can then look at the big right-angled triangle to find our x. We've got 11 here, we've got y here, and we could say that that's equal to 9.22 now. And it's a hypotenuse that we're trying to find, so we can add again. We can say 11 squared plus 9.22 squared is equal to our x squared. If we put that all together, we'll get something like 206. If you can avoid rounding, you'll get exactly 206, otherwise you might get like 205.9. And then if we want to square root it, we'll square root our 206, and we should get 14.35 centimeters. So that's great. We've worked out this is 14.35, and we've worked out this is 9.22. We still haven't answered the question though, which is to find the perimeter and the area. Perimeter looks like the easier of the two. We're just going to need to add up all of the sides. We don't need to add up the y because the y is on the inside of the shape, but the perimeter is just going to be 11 plus 6 plus 7 plus our x, so plus our 14.35. That's going to give us 38.35. As for our area, well, that seems like it's going to be complicated. But it's not actually too bad, because we know how to find the areas of triangles. We know that they are half times base times height. So I'm just going to label these as triangle 1 and triangle 2. I'm going to put my 9.22 on the side here. The area of 1, well, the base is 7 and the height is 6, so we can just go a half times 6 times 7, which is going to give us 21. The area of 2 to half times, so the base of this one is 9.22 and the height is 11, which is going to give us 50.71. So our overall area is equal to those two areas added together, 71.71 centimeters squared. Okay, and let's consider one last question involving a parallelogram. And again, we're talking about area of parallelogram. That's just base times height, by the way. Given it's got a perimeter of 68, feels to me like it would be useful to work out this side here. We've got a ready-made right-angled triangle here. So let's do that. We've got x and 8 and 15. Our hypotenuse is the x, so we're going to add to get what that is. 8 squared plus 15 squared gives me 289. So I need to square root that to get x, which ends up just being 17. So let's fill that in on the diagram. We've got 17 and 17 here. We're told that the perimeter of this whole shape is 68. And if we think about maybe splitting it like this, we can say, well, this is 8 here, from there to there. And then this is something we don't know. Let's call it y. And this is the same thing we don't know. And all of those numbers added together have got to give us 68. So we can say 8 plus 17 plus y plus 8 plus 17 plus y. That's all the things on the outside of the shape equals 68. Bring together the 8 and the 17 and stuff, and we'll get 50 plus 2y is equal to 68. So we'll get 2y is equal to 18 and y is equal to 9. So that means that the bottom of our parallelogram is just 17 because it's 8 plus 9. So go back to our diagram. We have got a parallelogram where this height is where the base is 17 and the height is 15. So our area is just 15 times 17, which is going to be 255, again, centimeters squared.